Well, hello folks. Here I am back again for the second time today, and this particular video is in response to a discussion that I had with about 5 flat earthers at a time, and one pretty noisy one kept insisting that we don't make predictions using any models. We simply rely on past experience. So he says everything that we do is based on some past experience. So it occurred to me that if he was right, if you look down here, okay, that there would have to be a Flerth book of experiences. This is where we go and dig up the experience that we're after and see if some other person has done it, and this will tell us what we're going to get. So let's say, for instance, I've got a chemical reaction going and I want to find out how much I'm going to get. Then I go to the Flerth book of experiences and I seek out that particular reaction, have a look for the occasion when some chemist did the exact same thing that I want to do, with the exact same quantity, with the exact same conditions, and then I can see what that chemist got, so I don't have to make any predictions, because of course the chemical reactions, the equations that I do are of no value at all. They're not there to make any kind of predictions. They're just there to have some nice letters and numbers on the board, and have nothing to do with how much stuff we make. Moles is not a thing. Apparently atoms don't even exist, and we just put stuff together, and everybody who does that records it in the Flerth book of experiences. This is where you go and you find out how much stuff you're going to get. Okay? Alright, well, I'm going to change things around. I'm going to see if we can actually make predictions. Okay? In other words, we're going to see what we can make some predictions. Now, in this particular case, this isn't chemistry, this is physics. So what we have here is we have a helicopter, and this helicopter is dropping a package. The package is 75 kilograms. The helicopter is 1,000 meters up, and we want to see how long it will take for this package to hit the ground. Okay, so let's have a look at the question. The 75 kilogram, that's 165 pound in the old language, package is dropped from a helicopter hovering at 1,000 meters. That's 3,280 feet or thereabouts in the old language, and air resistance is negligible at this stage, because I mean we're talking about something that's quite heavy. So 75 kilograms of mass is quite substantial, and of course air resistance would be negligible compared to the rest of that. Okay, so our first question is, how long will it take for the package? How long will it take for the package to hit the ground? That's the first question. And the second question is, does the mass of the package influence the time that it takes for the package to hit the ground? Two very interesting questions that we could ponder over, and let's see if we can make some predictions on that. Well, it just so happens that this chap called Newton, he actually did make some stuff, did some work on that, and did make some predictions, and actually wrote a very substantial model on this. And here it is, right there. So he predicted that the distance is equal to the initial speed times the time plus half of the amount of gravity, acceleration due to gravity, half of that, times the square of the time. Okay, so this is the formula that's made, that he derived to work this out, to be able to work out this time. And what have we got here? So we got S is the displacement. Okay, that's this displacement. from there to there, from where the helicopter dropped it to the floor. That's S, and that's the 1,000 meters. And then U is the initial velocity. In other words, what was it doing at the time that it was dropped? And obviously, if it was in the helicopter hovering, the helicopter wasn't going this way or that way, then you just dropped it, so it went straight to the ground. Okay, so you would say that it was at rest. Okay, I mean, relative to the helicopter, it was at rest, and relative to the ground, it's at rest. Okay, so then is drop the package, which is a 75 kilogram package. This is no small feat. You know, an actual flurfer would weigh that much. Okay, 75 kilograms. All right, so dropped it down, and negligible air resistance. Okay, we've got T is time. That's in seconds. G, acceleration due to gravity. Acceleration due to gravity. Oh my God! Look at that word. Actually, I've highlighted it a bit just so you would look at it again. Yes, acceleration due to gravity, 9.8 meters per second squared. And how do we know that? Because thousands and thousands of things have been dropped. And guess what? They all accelerate to the ground at the same rate, 9.8 meters per second squared. I don't even think flurfers disagree with that. So, we put gravity in there. That's acceleration due to gravity. Gravity! Okay, 1,000 equals 0t times half, 9.8 times t squared. So we plug in the figures, and we find t is the square root of 1,000, which is this, 1,000 over 4.9. And what is it? 14.3 seconds. So if that thing's up there, it's got a 75 kilogram package, and you drop it, 14.3 seconds before it hits the ground. So if you are somebody up there and you fell out of the helicopter, you've basically got a little bit of time to think about what's going to happen. Okay, 14.3 seconds of it. Okay, alright, so really that's it. What about this next thing? Does the mass of the package influence the time that it takes for the package to hit the ground? Well, I would say that even the least thinking flurfer around would realize that this formula over here does not have any mass attached to it. You notice that 75 kilograms? I didn't use it. There's no mass attached to this formula. So why would it make a difference? If that was 750, I still wouldn't be using it in this formula, would I? So therefore, it doesn't matter, does it? You know why it doesn't matter? It doesn't matter because everything falls to the ground at this rate. And if you like, this shows you that everything falls to the ground at this rate, because if this does make that prediction, using this, and at no time over here are we using the 75 kilograms, it shows that it doesn't matter about the mass. Everything will fall at the same rate. Now, plenty of experiments have been done to prove that, including a very famous one done by Professor Cox. If you haven't seen it, you ought to. It's quite an interesting experiment. Okay, that's enough for this particular bit of it. I said it was going to be short, and if you like the videos, then please press the subscribe button, and if you don't like the video, press dislike. Okay, now you flurfers, go ahead now. Ready, set, go. Dislike, bang, 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 smash it. Okay, you ordinary people, the ones that come with a brain, just hit like, please. Okay, good on you. See you next time.